Table 4 contains the WASD balance sheet for corn in August 2016. So let's take a minute and get oriented to the rows of this thing and the columns, and then we'll talk about each number in a little bit of detail. So here we have a group of rows called million acres, and we have an area planted and an area harvested. So this says here that 94.1 million acres is expected to be planted and 86.6 is expected to be harvested. Talk about what the columns mean in a second. Then we separate out the bushels so that we can get a yield per harvested acre number. And you can see that this is looking like a typical corn yield for about this time. So 175.1 bushels per acre was the expectation in the August 2016 WASD. And those rows are really just for reference because people often want to know the acreage number and they want to know the yield number. From a balance sheet perspective, this is the number that's important, and that's the current production number. So remember, we talked about how we always bring forward the beginning stocks that were ending stocks from the previous year. So here's the beginning stocks number. 1,706 million bushels were brought forward into the 2016-2017 marketing year. Production was 15,153 million bushels, so that's like 15.153 billion bushels. And you should be able to take this number, area harvested, times yield, and get this number here. We'll see some examples of that in a little bit. And then how many million bushels did we import? We imported 50 million bushels. And so total supply, as we noted in the general column, should be beginning stocks plus production plus imports. Next, let's talk about the demand rows, and that's everything from here all the way down to here. So I'm going to skip the feed and residual row for a minute. What makes up the food, seed, and industrial is exactly that. So we use a portion of the corn that we produce to make things like tortilla chips, and we keep some back for seed. But the bulk of this category is actually ethanol production. And so it's reported in the WASD table in its own line. So you can see here ethanol and byproducts is 5275, but that's actually a sub part of this. So you have to keep in mind, that's why I have it italicized, that people always want to know what is the ethanol number, so they write it out below. But really this is its own category, so you don't want to be summing these two things twice when you're trying to figure out total use, because that will give you too much, because this is inside this. That's most of the domestic category, except for this row that we haven't talked about yet, so I'm still going to come back to that. Exports are self-explanatory. That's how much corn leaves the country as export. And then we have our ending stocks number. Now, and of course, as we mentioned, that's how much is left over after we use everything that we're going to use that year in all of those different categories. Now, what this row here, feed and residual, is intended to measure is pretty much, is supposed to be how much feed we use in livestock feed, how much corn we use in livestock feed, and that's a significant portion. You see, we basically feed as much corn as we produce ethanol, and those are very much the largest parts of how we use corn in this country. But it turns out that it's not easy for the USDA to estimate this category, feed and residual, because cattle feeding happens in a very disaggregated way. There's hundreds or more like thousands or tens of thousands of entities who are feeding corn to livestock, and it's very difficult to keep tabs on that. It is a little bit easier actually to survey and ask people how much corn they still have in stock. So what they do to get this number is they basically solve for it algebraically. They say how much is our total supply, and I'm going to subtract the use in this category, subtract exports, and subtract stocks. So basically subtract everything else and come up with this number for this category. So we're going to have a part of our lab will be verifying that this works out. numerically, and then you can take my word for it that that's how they actually do it. So the last thing about the balance sheet is this final row where the USDA gives you a price forecast. And as of today, they are providing interval forecasts. So they're saying as of August 2016 that the season average farm price for the 2016-2017 marketing year will be between $2.85 and $3.45 per bushel. Now that's not a confidence interval, that's nothing. They don't assign any probabilities to that interval or the likelihood that the price will fall within that range. They just say it's going to be in this interval. So I haven't yet fully talked about what's going on with the columns of these categories. So I've scrolled back up to the top. And as you can see, if you look across the top here, the column that's on the rightmost side is actually the current projection. So this report, recall, was released in August of 2016. And this is the marketing year 2016-2017 projection that was released in August. So it's the balance sheet forecast for the crop that was just about to be harvested in 2016. If you look one column to the left, it's the projections for the same marketing year, 2016-17, but that were released a month prior. And they always do it this way. They show you what they said last month, and they show you what they're saying this month. That way you can easily compare and see what has changed. You can see in this that the acreage number did not change. Neither the planted nor the harvested acre number changed, but they did revise significantly up the yield number in 2016 from 168 to 175. That's actually a pretty big revision upward for a 1 month. Okay, now you look one more column to the left and you see marketing year 2015-2016 estimate. So that is the balance sheet that they have most accurately estimated for the last crop year, the last marketing year. So this is the estimates for the crop that was harvested in fall of 2016. And it's listed as an estimate in August 2016 because these use categories are still being updated. So they have a pretty good handle on what the area planted and harvested and yield were in a year ago's balance sheet estimates, but they're still revising the feed and residual and the food, seed, and industrial and the export and all of that stuff. So they provide that there, and then they also provide even a year before that, so marketing year 2014, and those no longer say estimate because as of like 2 years later, they feel pretty good about that they've got those numbers pinned down. So that's the USDA WASDE balance sheet for corn. Let's scroll down and take a look briefly at the WASDE balance sheet for soybeans. So table 5 is the WASDE balance sheet for soybeans from August 2016. You'll notice if you take a look across the column headers, those are exactly the same as for the corn WASDE report. And that's because they kind of format these balance sheets in pretty similar ways for anything that's a crop that's planted and harvested like this once a year. You'll also notice that the supply rows are very similar. We've got area planted, area harvested, yield per acre, and beginning stocks, production, and imports. Those function exactly the same way as in the corn balance sheet. So for example, you should be able to take 3 times 50.6 and get 4201. Now this is a good time to note that these tables can be off by a little bit due to rounding. So I just did on my calculator literally 83 times 50.6 and I get 4199.8, which is not exactly equal to 4201. But if you go and you look at the actual WASDE report, there's always a big asterisk at the bottom that says table rows may not add due to rounding. So we have to contend with that. But that's where that column comes from, or where that row comes from. So let's talk about the use rows briefly. They are a little bit different for soybeans because we use soybeans for different things than we use for corn. Particularly, soybeans are not all that useful in their whole form. They're kind of a little hard little ball. We don't use them in their whole form all that much. We either export the soybeans whole or we crush them if we're going to use them domestically. Domestically, we after we crush the soybeans, what you get is soybean meal and soybean oil, which we'll talk about a little bit more in detail when we focus on soybeans a little bit. But you get soybean meal and soybean oil. Soybean oil is useful for a variety of things. It's used for human consumption as an edible oil. So you can go to the grocery store, buy soybean oil, and fry with it. And soybean meal is a very valuable animal feed because it has a pretty high protein content. So it's used in that capacity. What we don't crush, we export, and we keep a little bit back for seed, obviously. And then there's also this residual row here, which is computed in the same way. It basically is found by taking the total supply and subtracting off all the other demand columns, and you get a residual row. And likewise here, the ending stocks are actually estimated rather than derived, but it should be the case that total supply minus total use equals ending stocks. And remember that you can't get too hung up off of the rows exactly adding the way they should because of rounding. And then they also give you the same kind of interval price forecast as they did for corn. So one note about those prices, it's pretty scientific, at least statistically scientific, how they come up with the balance sheet rows for all of the supply and the demand rows, but the price is kind of an art form. You should have a general sense that that price number should be related to ending stocks because, as we mentioned a little bit earlier, if ending stocks are low, that means demand is high relative to supply, and that probably means we should have a high price. If ending stocks are high, that means that the stuff is plentiful and there's not really enough demand for the commodity to use it all up as much as we produced for that year. So since it's plentiful, it should probably be low in price. But actually putting down a number, once you've even figured out the ending stocks, is not an easy thing to do, and that's part of the reason why they're giving you an interval forecast and why that interval is quite wide. So anyway, we will explore that in more detail in future chapters as well. So that sums it up for chapter 6. In the lab for this week, we're going to take one of these balance sheets and actually compute some of these, some of these computations ourselves. So that'll get us used to it should really drive home which numbers the USDA has to estimate and which numbers that they have to just derive by doing simple arithmetic within the balance sheet table. So hopefully that will help us drive that point home. See you soon.